In this video, we're going to talk about Newton's second law. So I'd like to start off with this grocery cart right here. So imagine you're at the grocery store and you have a grocery cart and you have some items in here. And if we were to collect some data on the acceleration of this cart based on the force, let's say you were to push it at varying amounts of force and we measured the acceleration, we would get a graph that looks like this. So if we have acceleration on the y and force on the x, we would get a graph that looks like this. And this would be a directly proportional relationship. So as you increase the force, the acceleration increases. And hopefully that kind of makes sense. So if you push the grocery cart harder, there's going to be a greater acceleration. Now let's say we keep the force constant, and this time we vary the mass. So we're once again going to measure the acceleration, and we're changing the mass. So before you have, maybe imagine you put in a bag of oatmeal, and then now you put 2 bags of oatmeal, you measure the acceleration with the same force, and then now you put 3 bags of oatmeal with the same force, and you measure the acceleration. What would this graph look like? So what's going to happen is that as you have more mass using the same force, the acceleration is going to look like this. The acceleration versus mass graph will look like this. So this is called an inverse relationship. So as the mass increases, the acceleration decreases, and that should make sense with the grocery cart analogy. You're pushing on this grocery cart, you put in more items in here. If you push with the same force, you're gonna get a smaller amount of acceleration. So we can write this relationship as follows. Acceleration is directly proportional, so directly proportional to the net force, and it's inversely related to the mass. Mathematically, we can write it this way. The acceleration is equal to F net. Here's the net force divided by the mass. Sometimes you'll see it written this way, acceleration equal to sigma, the Greek letter sigma, F. That just means net force divided by m. Okay. We can also write it to solve for the net force. We can write net force equals ma. I like it written this way when you start learning it initially because I think it makes more sense. You have a greater net force, you're going to have a greater acceleration. You have a greater mass, you're going to have a smaller acceleration. But later on, when you're solving actual problems, this sometimes can be easier to use. Now, before we solve some actual problems, let's take a look at this idea of net force. What do we mean by net force? So when we say net force, we're talking about the sum of the forces. And force is a vector. Force is a vector. So if the forces are in the same direction, we're going to add them. If they're in opposite direction, we're going to subtract them. You'll see some examples as we do these right now. Okay. So first, let's just start with something basic. We're going to start with one that has just one force. Okay. So here's an object. Let's say this is 2 kilograms, and we have a force to the right of 8 newtons. Okay. And I want to know what's the acceleration. So the acceleration is the net force divided by the mass. So it's just going to be 8 divided by 2, and we get 4 meters per second squared. And the unit for acceleration is meters per second squared. It's telling you how quickly the velocity is changing every second. Okay. Next, now let's take a look at an object where we have more than one force. Okay, so this is a 3 kilogram object. It's being pulled to the right 12 newtons. To the left, a force of 4 newtons. And to calculate the acceleration, we first need the net force. Okay, so the net force here, let's go and calculate that real quick. They're in opposite directions. We subtract them. So 12 minus 4, we get 8 newtons. So over here, I'm going to substitute for the net force. Let me just write the equation down again. So it's going to be 12 minus 4 is 8 newtons divided by the mass is 3. So 8 divided by 3, and we get 2.7 meters per second squared. In our next problem, we're actually going to have 4 forces. Okay. And our object in this case is also 3 kilograms. We're going to have a force going up 3 newtons. Force going down, 3 newtons. Force to the right, 2 newtons. The force to the left, 2 newtons. Now what you're going to notice is that all these forces are balanced. So there's 2 newtons to the left, 2 newtons to the right. Those are balanced. 3 newtons up, 3 newtons down. Those forces are balanced. So the net force here is 0. If the net force is 0, we don't even need to calculate because 0 divided by anything is still 0. So the acceleration will be 0. Well, what's an example of this? Does that mean that this object is not moving? No, this object could be moving. So let me show you an example of this, where an object could be moving and the forces are balanced. So here's a plane, okay, and here are some forces. We have gravitational force, okay. We have a lift force. We also have thrust, and then we also have air drag or air resistance. Okay, so this plane, this would be an example of a situation where the forces are balanced. The forces are obviously going to be bigger than those, but the forces are balanced in this situation. And if the forces are balanced, then we know it's either at rest. In this case, it's not at rest because it's moving, or it's moving at constant velocity. So in this case, the plane would be moving at constant velocity. If this force was bigger, it would speed up. If this force was smaller, then it would slow down. All right, we'll take a look at another example. In this example, we have 2 forces acting on the object. The object has 4 kilograms, has a force to the right of 5 newtons, and a force to the left of 2 newtons. And we want to find the acceleration. So we're going to first figure out what the net force is, and the net force is, if they're in opposite direction, we subtract them. So in this case, it's going to be 3 newtons. The equation is net force divided by mass. The net force is 3. The mass is 4. So we'll get 0.75 meters per second squared. Okay. Next, we can also have forces that are occurring vertically. So let's take a look at this problem. You can have an elevator, for example, that's moving vertically. In this problem, we have a force up of 3,000 newtons and a force going down of 2,500 newtons. And let's say that the mass was 250 kilograms. Okay, so how do we solve this? So we're going to use our Newton's second law equation, net force divided by the mass. The net force is 3,000 minus 2,500. The reason I'm subtracting is because they're in opposite directions, divided by 250. Okay, so from here I get 500 divided by 250, and we get 2 meters per second squared.